geometry. It's been a long time since we've done something productive in class, but we are back to it today. Starting Unit 6, which is all about right triangles, and we're starting with the Pythagorean Theorem. In the video that we just watched, you kind of got the nuts and bolts of it. Remind us, Pythagorean Theorem, what is the formula? What's the equation? Peter? A squared plus B squared equals C squared. I'm going to write that kind of backwards. I'm going to say C squared equals A squared plus B squared. And the reason for that is because in the next objective, CO40, this equal sign will become a greater than symbol and a less than symbol. And it's easier to remember what happens in those situations if the C squared is first. Okay. Obviously, since it's equal sign, A squared plus B squared equals C squared is the same thing as C squared equals A squared plus B squared. It doesn't make a difference. But in order to kind of prep for CO40, I'm going to write it like that. What type of triangle does this have to work with? Does it only work with? A right triangle. And when we talk about A, B, and C, where do we find A, B, and C? What sides do A, B, and C correspond with or represent?
C is the one opposite of the right angle.
Right. C is always the longest side. It's called the hypotenuse. Okay. That has to be the side opposite the right angle. The other two sides, A and B, are interchangeable. Doesn't matter which one's A and which one's B. They're called the legs of the right triangle. Okay. And we primarily use the Pythagorean theorem when we're looking for the third side of a right triangle when two sides are known. You can't use the Pythagorean theorem when you only know one side, because then you've got two variables and one equation to solve for, and we know all the problems that brings with it. Okay. The video also talked about 3, 4, 5 triangles, and said that a 3, 4, 5 triangle or any ratio of that will always be right. So if you memorize these, I think we talked before about the ACT. It's 60 questions in 60 minutes. Okay, no one's really expected to finish all of them. It's a test of mathematical knowledge as well as efficiency. And memorizing these Pythagorean triples, at least the first two, will serve you well with that. For example, if you know that the legs of a right triangle are 3 and 4, and you've memorized the 3, 4, 5 Pythagorean triple, you don't have to calculate anything. If you see legs of 3 and 4, you know the hypotenuse has to be 5. Okay? The same thing is true for if you saw something like legs of 6 and 8. What would the hypotenuse of this right triangle be? 10, right? You double 3, double 4, double 5. It's in the ratio of 3 to 4 to 5. If you had a triangle that was 50 to 120, what would the length of the hypotenuse be? 130. Okay. So these are just here, not so much, just like an FYI, that if you know these Pythagorean triples, you can kind of spend less time on some of these problems here. Okay. We also cover simplifying the square root, because that is something that you'll need to do for this. Never mind. Okay. Who can remind us how to simplify the root of 18? How do we simplify the root of 18? Not to get a decimal value now, right? But to simplify it. This goes back to PO39 that we did the first month of the school year.
So like maybe take out a root that can't be simplified.
Like right. We're looking for that perfect square factor. You know, root 18 can be rewritten to be root 9 times root 2. Just ring a bell? Yeah. The root 9 is what we want, because that can become 3. And then the root 2 can be simplified further. 3 root 2 would be the simplified form. Okay, we would not want to break root 18 up into root 6 times root 3, because those aren't perfect squares. We can't do anything with them. Even though simply multiplied to be 18, they lack that perfect square. Root 40, what do we simplify root 40 to be, or how do we break it apart?
Root 4 times root 10.
Yep, root 4 times root 10 to get 2 root 10. Root 175? Blake?
5 root 7.
Root 25 times root 7, which gives us 5 root 7. 600? Root of 600?
106.
Yep, root 100, root 6 gives us 10, root 6. So it might behoove you to, if you don't know your perfect squares, jot them down on help sheets. You have them, your 9, 4, 25, 100, 36, 49, you know, all of those things that you can use to help simplify roots. Questions so far? Okay, so let's practice. You've got 4 right triangles here. It's pretty easy to tell which angle is the right angle. I think it's the 1-pager. Yes, it is. Okay. I didn't draw it in here, but I will now. That's your right angle there, right angle there, there, and there. Let's start with the one in the upper left. Using the Pythagorean Theorem, c squared equals a squared plus b squared. And again, if you wrote the other way, it doesn't make a difference. Okay, don't erase anything. But what would we put in the various places here? What values do we plug in for a, b, and c? Will? 4 for a. Would it matter if you put 4 for b? No. Right? But the 2 legs of the right triangle, the 2 sides that make up that right angle, 4 and 6, they are going to be your A and your B. It does not matter which one's which. Our n, our hypotenuse, if you want to leave it c squared, if you want to plug in n, doesn't make a difference. It's the relationship, right? That is the position where the hypotenuse length goes. Following order of operations here, we would square first. This would not be 4 plus 6 to get 10, then square 10 to get 100. It is n squared equals 16 plus 36. N squared equals 52. And because we are PERMDAS people, we know that to isolate that n, we would root both sides. So n equals the root of 52, which can be simplified. Gino?
Yes.
Yes, how?
4 root 13.
Root 4 times root 13, which would give us the final answer of 2 root 13. That's it. There you go. Okay. Let's look at the next one. Someone set up the equation for me. Next one being the one to the right. Cindy.
10 squared plus 8 squared equals 10 squared.
10 squared plus 8 squared equals n squared. Our legs of 10 and 8. Very good. Square each of them. We're going to add them together. That equals hypotenuse squared. So this would give us 100 plus 64, or 164. The root of 164 equals n. And how does that one simplify to be? Great. 2 root 41. So 4 times 41 equals 164. We have that perfect square of 4, and we get 2 root 41 as an answer. Okay. You can also use the Pythagorean theorem when you know the hypotenuse and want to find one of the legs, right? It said the condition was you knew 2 of the sides. Doesn't matter which 2 of the sides you know. You just have to carefully set it up correctly. So in this third example here, the hypotenuse of 12, we are given that. So 12 squared equals 3 squared plus b squared or n squared, whatever you want to use, right? But in this case, we're solving for one of the legs. Okay, in this case, we're solving for one of the legs. So when we square this out, 144 equals 9 plus b squared. You have to move that 9 over, right? Just like you'd solve for any other variable. So we get 135 equals b squared. Root both sides. We get the root of 135 equals b, which I hope can be simplified because I'm almost out of space on my board. I don't think it can be. Oh, it can be. Shoot. How can root 135 be simplified? Caleb?
Root 9 and root 15.
Root 9 times root 15, which ultimately gives us 3 root 15 as an answer. Okay. Last one. Who can do the last one mentally? Joey?
It would be 6.
How do you get 6?
It's in the 3.5 ratio.
Oh, it's in the 3-4-5 ratio, right? We have a leg length of 8, hypotenuse length of 10. That follows the 3-4-5 because we have the 8 as a leg, the 10 as the hypotenuse. The missing leg here would have to be 6. If you worked it out, it would work out to be 6. But there's an example of knowing that Pythagorean triple. Save us some time and effort. How are we doing?
Good.
Yeah? Oh, of course there's homework. Something this fun, Gino? How can there not be? Okay. Your homework is on page. Let's see here. 437. No way. 436.
Like, you better get bold.
I'm gonna have you do 3 to 5.
Bold was another one.
3 through 5. This is all finding the hypotenuse. Then on page 437, 14 through 16. This is finding legs. And I'm gonna do a couple challenge questions here. 24 through 26. And 31.
Wow.
You do need to show work, however, you do not need to write your answer in simplest word form. Some of these numbers get rather large, so decimal answers are fine for this assignment. Okay? Decimal answers are okay. But work does need to be shown. Work does need to be shown. Questions, comments, concerns, complaints, comments, congratulations, or criticisms? You haven't had math homework in like a month, so I feel like this is okay.
But
Okay, so there you go. All right, hop to it. That's how you math. I can't do this anyway. Don't forget to like and subscribe. I gotta fix my board.